All right, good morning. Welcome back to Calc 2. So today we are going to continue our discussion on double integrals, and we'll see what we can get to. So let's go ahead and share the screen. All right, and we'll go ahead and take a look at our homework. We may have already started this one, but we're just going to go from here. Okay. So here's what we have. We have z is equal to, okay, 4x squared plus 2. We've got over the interval x to 2 and 0, y to 4. Okay, so what kind of okay, so again, we're going from numbers to numbers. So this is a rectangular sort of a base, so we can swap the order, it doesn't matter. Okay, and oh, that's convenient. So what we're going to have here is we're going to have a 4x squared plus 2. We have a base, we have a 0 to x and a 0 to y. So this is, even though this looks like a two-dimensional function, you know, because it only has x's in it, the y is still kind of implicit. Okay, so we still have dx dy here. Okay, let's go ahead and do it this way. Okay, so I'm going to write my x's here. So it's going to be from 0 to 2, and this is going to go from 0 to 4. All right. It doesn't matter which order you do this in, but I don't like the bigger numbers, so I'm going to think that if I get rid of this first, then tackle the y, it's going to be a slightly smaller operation when I get to the y part. Okay, so all we have to do is integrate this thing with respect to x. So this is going to be, remember this is the y's, okay, this is going to be 4x3 over 3 plus 2x, okay, just integrated with respect to x from 0 to 2 dy. Okay, so what we're going to have to do here is we're going to say this is 4/3 times 2 cubed plus 2 times 2 minus 4/3 times 0 cubed plus 2 times 0. The minus is here. And this is integral from 0 to 4. This is x evaluated at 2, x evaluated at 0, dy. Okay, now that's a mess. I mean, fortunately, this part here is all zeros, so this one is 0. So we just have to deal with this nonsense here. So we have 0 to 4. Okay, we have 4 cubed. 2 cubed is what, 8? Okay, plus 4 y. Okay, so it looks like we have 32 thirds plus, I'm going to say 4 is equal to 12 thirds. Okay, so we have plus 12 thirds dy 0 to 4. 32 and 12 should be 44, so we have 44 thirds dy 0 to 4. Just integrate 44 thirds dy. It's 44y. 44 over 3 y. Okay, dy turns into a y. When we integrate from 0 to 4, plug in 4 minus 44. You don't have to write this part. Minus 0. So we just get 44 times 4 over 3, and we're just going to write that down. So if we say 44 times 4, 4 times 44 is the same thing, divided by 3. Okay, now they're not going to like this. Okay, so if you did end up doing this value, what you're going to do here is you're going to go back to math. So this first one here is fract. It's going to convert everything into a fraction. Okay, so we get back to 176 over 3, and that's the answer they're going to want. Okay, so this is 176 over 3. All right. Okay, So this one is a little bit more tricky because sometimes which variable you choose will make a difference, okay? So I'm looking here at this x e to the xy business. Do you remember trying to integrate? Right, if we just wanted to integrate x e to the x, like that was an integration by parts, right? Y. So since 0 goes from 0, x goes from 0 to 8, y goes from 0 to 1. Okay, and there's a y in here. I'll tell you what, why don't we put off having to deal with the integration by parts until we've dealt with this y? Okay, maybe we'll get lucky. Maybe we have to do integration by parts, which would be really lucky. But why don't we see if some things like clear up if we just deal with this y first. This is not always going to be the case. Okay, sometimes you're going to have to do it, you know, the hard way both times. But yeah, if we can, let's see if we can't put this off. Okay, so we're going to go dy dx. We'll put the y's in here, so that's 0 to 1, 0 to 8. Okay. And let's see here. I'm trying to think if they tried to telegraph this in some way, like maybe doing this. But I did another problem like this earlier, and they didn't. So let's go ahead. If I had to integrate this, right, the x's right now are constant. So really what we're dealing with is a e to the a y from 0 to 1 dy. Okay, you can think about the x's as constant. So this is the kind of thing I want you to see when you're looking at this. Okay, even though they're x's. So what will we do? We said we'll let u equal a y, du equals a dy. Okay, and then we can see if we can't substitute because we have an a dy. So we're going to go from 0 to 1 of x e to the xy, 0 to 8 dy dx. All right, and we're going to say let u equals xy, and then du is equal to x dy. Okay. Do we have an x dy I can replace? Yeah, we do. Okay, so this is going to be from 0 to 8. Okay, this is going to go from u0, u1 of e to the u. Okay, the xy, right, is u. And then x dy is du. We still have a dx out here. Okay, but now we have to integrate e to the u. Okay, that's probably the nicest thing anybody's ever done to me. Okay, and then this is going to go from u sub 0 to u sub 1, 0 to 8 dx. All right, and then what we're going to do is say 0 to 8, and then we're going to write what's u? U is xy, wasn't it? And then we're going to go from 0 to 1 now because we're back in our y world, dx. So evaluating 0 to 8, we have e to the x times 1 minus e to the x times 0. Okay. So this is going to be from 0 to 8, e to the x times 0 is 0, and e to the 0 is 1. Okay. dx. And now we have this to integrate. Not so bad. Right, this is going to be e to the x minus x from 0 to 8. Okay, so e to the 8 minus 8, that's the first bit, minus e to the 0 minus 0. What is e to the 0? E to the 0 is 1. Okay, so this is e to the 8th minus 9. And there's our answer. E to the 8th minus 9. Okay, Exact answers in terms of E. Very good. All right. This one, a little tricky, okay, because they're giving us a bound here, saying we want you to do this bounded by this business here. Okay. So let's go ahead and turn the page. So we've got a region. Okay. We've got 3x squared y dy dx. Fortunately, they gave us this first. And they said bounded by y equals x squared and y equals 2x. Okay. So what I want you to do is think about this as an x, y. Okay. And what we have to do is we have to figure out, like, where the heck do these things are equal? Okay, where is x squared equal to 2x? Oh, wait a minute. We could do that. We just set them equal to each other and then solve. So the x's go from 0 to 2, okay, and the y's go from x squared to 2x. Okay. Here's 2x. Here is x squared. How do I know the x squared is on the bottom? Take any value in this region and compare them. Okay. So what's a, don't pick 0 or 2. Okay, because there's the endpoints. What's a value in this region? Like 1. So when x equals 1, y equals x squared equals 1. X equals 1, y equals 2x equals 2. Oh, the 2x is bigger than the x squared. So make sure you draw them in the right order. If you don't, you're just going to get the negative. Okay, it's not the end of the world, but you have to realize, like, which one is bigger. Okay, so 0 to 2 for my, for my x's, and we have x squared to 2x of 3x squared y dy dx. Okay, I kind of like this one because they told us, like, which way to do it first. So I think with that hint, that implicit hint, that this wouldn't be quite so bad. Okay, but that this would be about as hard as it gets. Okay. When I took Calc 3, this is when the engineering students do this, is in Calc 3. A little bit of Calc 2, but mostly in Calc 3, because that's when you get the double integrals. This was like a 2-week or 3-week part of the class. I mean, this was huge doing this. It was delightful. Okay. So that is our setup. Okay, so let's integrate with respect to y, because this bit here, this can flip through. This is just going to be 0 to 2. We have a 3x squared here. We have an x squared to 2x of y, the y squared, just y. Okay, and we have our dy and our dx. Okay, so let's integrate with respect to y, because that's our job. So this is 0 to 2, 3x squared. Okay, this is y squared over 2 from x squared to 2x, and then we still have to integrate with respect to x. But we have to do this stuff first. Okay, we have to do that first. So I'm going to move the 2 over here. So we're actually going to say this is 3/2 integral 0 to 2, because 3 divided by 2, 3/2. We have an x squared, and then we have, these are going to be squared. So we're going to have a 2x squared, it's y squared minus x squared in for y squared. Okay, so be careful about that. This is a little tricky. Okay, that's why we move stuff away, so that we can just concentrate on the parts that are going to be hard without having a lot of stuff in here to keep track of. Okay, so we have our 3/2, 0 to 2, x squared. Can't move the x squared through because we're still integrating with respect to that. but we have to square this. Okay, so 2x squared, that's going to be, you have to square both of them. So that's 4x squared minus, when you have a power raised to a power, you multiply them. So that's x to the 4th. And then we're going to go ahead and distribute the x squared in here. Okay, so it's going to be 3/2 integral 0 to 2. Okay, this is going to be 4x. When the bases are the same, we add the exponent. So that's going to be a 4. When the bases are the same, we add the exponent. So that's going to be a minus x to the 6th dx. Okay, now let's go ahead and integrate. So we have 3/2. Okay, we have 4x to the 5th over 5 minus x to the 7th over 7. Okay, and then we have to plug in from 0 to 2. When I plug in 0, right, we're going to 0 and 0. So that part, this part here is just going to be 0. So we really have to face when x equals 2. Okay, so we have 3/2. We have 4/5 times 2 to the 5th minus 1/7 times 2 to the 7th. Okay. So we could do this. We could say this is 3/2 times 4/5. 2 to the 5th is 32. Okay, minus 1/7. And if I remember my intro song here, we have 32, double it, that's 64. So that's 2 to the 6th is equal to 64. 2 to the 7th, double it, is 128. Okay, so that's my intro song. All right, that's what we have to deal with. All right, I will use the calculator at this point. Okay, so we can say 4/5, oh, turn on, 4/5 times 2 to the 5th, okay, minus, oops, just one minus, 1/7, 1/7 times 2 to the 7th. Okay. So what did I do wrong? Oh, I put a parentheses in there I shouldn't have. Ooh, I don't know how to get them back. Okay. 4/5 times 2 to the 5th. Okay. Minus 1/7 times 2 to the 7th. Okay, it's better. So we have 3/2 times this business. Okay. Again, they're going to want it as a fraction. Okay, so if you did it this way rather than do it the long way, you're going to go to math, frac, enter. So the 256 over 35. Okay, so we have 3/2 times 256 over 35. Okay, so again, times 3/2. Let's see if it keeps it as a fraction. That didn't. Math, frac, boom. Okay, 384, 35. So, small prayer for Sister Mary Agony. She told me you cannot use a calculator to ever get your fractions, so you had to learn them. We didn't get along. I was not good at math in elementary school or junior high or high school. Okay. So 384 over 35. 384 over 35. Okay. All right. So that is how you do a problem like that. Okay. Let's see. You're there. All right. I'll tell you what. We are going to make this a 3-part problem because I still have a couple more problems to do. and these are going to be a little bit on the long side. So we're going to go ahead and stop here for a moment and then go on. Okay. So I will see you in the next video.